Okay, welcome back. So I'm just showing some of the most basic features of HistoloZee, starting with the interface and discussion of the coordinate systems involved in mapping slides to world coordinates. Back to the Data View tab of this first slide that we loaded, you'll notice that the slide itself consists of multiple resolution layers, the highest resolution being an image that's 60,000 by 47,000 pixels. The slide actually contains on disk 3 layers, but as we load the slide into our view, we generate 3 more downsample layers until we are below the 512 by 512 threshold. The reason for having multiple layers is to facilitate loading of such large images. We don't actually load the full resolution image all at once, rather we load the image in smaller low resolution chunks. And then as we zoom in, we load tiles of the high resolution images. Okay, so now I've discussed the orthogonal coordinate view docs. I'm going to just discuss the main slice view now. So we have a number of tools that allow us to navigate and transform this slide. First is the pointer tool, which you can access by the V button as well on the keyboard. You can see the shortcuts here in the tools menu. You can drag the view, and you can zoom the view. So all you do is you click on the location you want to zoom to, the crosshairs move to that location, and you drag upwards. And you can see that the view is eventually brought into the location that you clicked. The maximum allowable magnification in this software is 10,000 pixels per millimeter, which we believe is totally sufficient for most purposes. To zoom out, again, click and drag downwards. You can pan with the scroll bars. You can pan with the drag, and you can also pan with your laptop or external trackpad, which is quite handy. You can also zoom by pressing Shift and scrolling into the view with the mouse. Okay. Let's zoom into the hippocampus here. This is the dentate gyrus of the hippocampus. Again, notice that the orthogonal views are linked to the main slice view. And if we want to see a more fine-grained view of what we're doing, we can zoom into the orthogonal views as well. Now, what does this little button do at the bottom right-hand side of the orthogonal views? I'm going to just open this window up a little bit. Notice that each orthogonal view has a zoom slider itself, so you can zoom each orthogonal view and keep track of what the pixels correspond to in physical coordinates. I'll click this little button here. What it does is it locks the X, or the horizontal and vertical zoom perspective of your slice. Now, since this slice is so thin compared to its width and height, the slice appears almost invisible on the orthogonal view if we have selected this checkbox. Again, this is because the horizontal and vertical voxel spacings are 5 micron, are half a micron, whereas the thickness of the slide is 0.2 millimeters. And there are so many pixels in the slide. So I'm going to turn off that check and zoom out from the horizontal view and zoom into the vertical view. Now you can see a better representation of our slice. And you can drag these docs back into the main window at any time. Everything can also be resized as you like it. I'll just zoom out of the window here. Now, you will have noticed that there is a border around our slide. This border is broken up to show that this is the currently active slide. And the color of the border of each slide corresponds to the color chosen in this thumbnail view or under the view menu. So we can go ahead and change that to whatever we like. For example, sky. And there it is. You'll notice that there is a tint applied to the currently active slice in the orthogonal views. In this case, the tint is blue. This is going to be very helpful later on when we load multiple slides in a stack. You can also change the color of the slide by double-clicking directly on the thumbnail. And if you'd like to inspect the thumbnail in more detail, you can always just zoom in by resizing this table. All right. So we've learned about the Data tab. One last thing on it is this label figure, which is taken directly out of the Apereo SVS image. So most commercial slide scanning software appends a small label image to each slide just to show you any notes that were taken on it, including sample ID, slice number, etc. Let's move over to the View tab. So you'll have noticed that this slice is actually missing its background. How did that happen? Well, there are a couple of sliders here that let you do live image processing on your slice. The first is the Opacity tab. This lets you hide and show your slice and anything in between. I'm going to just hide the slice and zoom in to the window. And you'll see that the view is broken up into these boxes, each of which is itself broken up into boxes of size 10 by 10. And then as we zoom in, they get broken up further and further into boxes of size 10 by 10. This is just to help you obtain measurements quickly on slices. Let's zoom back into our slice. How did the background disappear? Well, there's this threshold tool. If we drag the threshold all the way to the end, the background comes back. We can threshold out to any value from the top or above, or we can threshold from the other side, taking out darker areas. Again, this feature is very useful if one wants to align multiple slices. The default setting should get rid of most of your background. If it needs to be fine-tuned, by all means, go ahead and change it. You can also just hide slices on the main view with this Show on Main checkbox, and hide slices on your orthogonal views with this checkbox. The W key is a shortcut to do the same thing. So W will show and hide this slice. The next view option is Edges. When clicked, it will show the gradient of your image overlaid on top of your view using the slide's current border color. So if we don't like that blue, we can go ahead and change it to salmon again. Now, these vertical, horizontal, and diagonal lines are actually an artifact of the GPU that I'm using in this laptop to demonstrate the software, but it should not appear this way on most desktop computers. You can change the magnitude at which edges are thresholded, and you can change the smoothing applied during the edge computation. So if you want to view large external edges, I suggest a high smoothing value, and if you want to view very fine edges, a low smoothing value. And as you zoom into your slice, these edges are recomputed on the fly. So you can actually view edges of cells at different resolution levels. For example, if I want to view these pyramidal cells in detail, I can adjust at this zoom level exactly the parameters that I need, and then scroll around. And as you zoom out, different features become visible using those same parameters, so we have to change those to suit our current zoom level. I will discuss the label view features in a future video when we do segmentation. Thank you. Next, I'm going to show you the basics of slide transformation.